Hello, this is the 3D printed animatronic creature part 6. This is the gimbal, but first I'm going to show you how I'm demonstrating how I'm doing some blockout. It's kind of testing where I want the skull pieces to go, how I'm going to enclose this whole animatronic. This is kind of like a sculpted sketch. Just seeing and knowing to where I can actually put these pieces at, and also just knowing, the foreseeing what I'm going to need to do to make this thing possible as far as making sure that everything is clear, all the mechanisms work. But I'm in Blender and I take a sphere and then I divide it uh, 3 times to kind of make a shape like this. Then I use the Blender modifier and go into mirror. So that way I can mirror this other shape on the other side, and works rather well because you can edit in low poly really easy. And then as you see here, I just stretch it out, and then I start adding the sculpting program they have on there, and I can just kind of manipulate it to this area of this so-called ring circle around the eyelids there. And what those are really there for, so my eyelids, when they're closed, don't bump that skull piece on the inside of it. And that way I can kind of model what I can on the inside of it, and then I can turn around and add something like this to the front of it, and that will be like a skull piece. So after I make the modifications to these pieces, I'll delete the main skull piece. But then later on, I'll just hit undo and it'll bring it back after I send this off as an STL file. And then I'll import it back into SketchUp, and then it'll match up correctly by matching the two software's center points, and I have it like so. And then I'm going to be able to manipulate this or come back and just redo it or make it thinner or more flatter underneath it to give it more room for the sculpture or whatever. But then what I do here is I take this circle to the skull, and what I'm going to do is I'm going to do a cutout. But before I do a cutout, I'm just going to go ahead and cut this skull in half, so that way I can just mirror it. What after the mirror, well, right here, what I do is I'll just extrude that piece, and then I'll move, where I feel comfortable, so it don't go too far. And then I'll just like move it over some, and then I'll go ahead and do the extrusion all the way through, and then I'll hit intersect with model, and then or intersect with faces, and then I'll just remove this entire sphere, and what little pieces are circled onto the skull, it'll be a round cutout area for where the eyelid's going to be. Later I will add the inside shell cover, or the shell version of this whole skull, and I can do it by copying this, reducing the size, and then making certain cuts to make it a solid piece, plus binding it to that so-called border area to the bottom plate. But here what I did is I did another STL file export into Blender. So now I'm going to add some more sphere shape brows, so this part will connect to the skull. So I just add a sphere into Blender, and then I'll just make my cuts and divide it into the basic shape that I need, and then also do the same modifier and do a mirror. This way I can just kind of, and it's just a simple low poly standard sphere. I mean, this is like I'm still testing. I'm just making sure that I have clearance around my eyelids, and that's the eyelids that are connected with the linkage, and that way they don't bump or come close to the inside of the skull and skull pieces. And plus, this will also have another cutout where the brow is, and where that ring is will also have a cutout because all that's going to be open, so because of the movement of the eyelids plus the movement up down movement of the brows. So once again, I'll delete the skull and the bottom pieces, and then I'll export this into SketchUp, and I'll just hit undo twice in Blender, and I'll bring it all back. But here I have the skull piece, and I see what I'm having to do, but now I'm looking at this and seeing that now this needs to go into it needs to go into ZBrush so I can put the skin on and see how that looks with it and see how much I need to adjust. But I need to design a gimbal, and that's going to be for the bottom plate, and the bottom plate it's going to be a small area there for the gimbal. So now we're going to build a gimbal, and we need a gimbal to be on the underneath of this skull, so it have a up, down, left, right, look all over the place. But to achieve this, we're going to need some parts, and these are the parts that I choose to use to make a gimbal. But and all these parts are available at Servo City or Go Build a, and these are good RC places where you can get servos, but they sell this little aluminum bracket or aluminum uh, plate here to go on a servo, and it has a bearing inside there where that hub is, and it gives it a lot more strength, and it's just more stable if you use that. And I would recommend this all the time. I mean, this is a really great piece. The only piece that I don't have designed is this hub right here, and I need this hub to make this gimbal possible. So I'm going to sketch it out. Now, all these files available on Servo City, they're step files, and you can download these and you can put them in your Fusion 360. Now, I can't put step files in SketchUp. So I can put STL files, and you can use another software called FreeCAD, and you can take the step file and you can change it into an STL file. But the thing about that is it's the time thing, and then on the other side of it is it makes it so much larger. It adds so many more vertices to it, and plus it's a from a milled software program or a file. So it's going to be a larger size file. So I'll just make a simple version of it because I'm not printing this. I'm just using it for measurements. So I just go by the schematic which they provide, and I just sketch it out, and I will always have this piece to put in my own library. I get a lot of these parts from Servo City, a lot of these aluminum pieces, and this the servo block is really made well, and even the beams I use, which I'm going to be using on this gimbal. But you just if there's a part you don't have, you can sketch it out. Plus, it helps you develop your skills in drawing or sketching. You know, just to have the piece in your library. And then now I'll probably use this piece multiple times in the future animatronics I make. Okay, now since I have this piece designed, now I can just place it. I can rotate it right here, and this little line that's sticking out, that's my guide, so I can place it center axis to the other object and just raise it up to where I need it. But now we're going to design a universal joint. I mean, I use universal joints for my large eyeball mechs, and usually the U-joint right here you're seeing is 22 millimeters long. Now, some of the smaller iMechs I use is 13 millimeters, and they're much smaller for smaller eyes. Now, a U-joint is what it's called short, instead of universal joint, is you have a center axis of this U-joint, and you have a center axis of a sphere. So if you line up the center axis of both, you will have the perfect rotation, especially of an eye. And the thing about it, I mean, if you see here, it's just so, it's perfectly centered. So, and you can see in some of my other eye videos how I determined to make this to fit my making of my iMechs. But it's a process, it's a learning curve, but you know, the benefits are great. But this is the rotation it does. So, you know, you have your left, right, and this is how, you know, a universal joint, you know, rotates. But what we're going to use it for, instead of moving an eyeball, we're going to move a head with it. But with this head that I'm designing, it's kind of on the small side, and this 22 millimeter U-joint, I've used them before, and I've had to buy other hub pieces so I can mount it to my animatronic heads to make the gimbal. So what I'm going to do is I'm going to make a kind of a poor man U-joint or universal joint. Now these aluminum brackets right here are mounting brackets. They're used to mount shocks, like RC shock absorbers. So, but I take them, and you can also make heavy duty linkages for them too. So I take it, and I take a 2-hole beam, and I have this 9-hole beam, and you should check these out. I'll send y'all the links to these beams, because these things help for large projects. I mean, these aluminum beams, there's a hole every 8 millimeters, a 4-inch hole. And on each end of the beam, there's a threaded hole for a 4 millimeter screw. But you see how I mounted this so-called U-joint to make a poor man universal joint. And it works great. So, but for me to get this thing to rotate, to move up and down and left to right, well, we have the left right because that's the servo on the bottom. That's going to rotate. So I'm going to need 2 more servos to move linkages to tilt the head. And I'm going to need something strong enough, because you got to also calculate it's going to have skin on it. And all the servos is just going to be the whole skull mechanism plus skin. So that's going to be a little weight. So I'd rather do overkill than under. So this is what I'm going to show you here. This is some of my library. I have a lot more servos that I design. So I just, you know, get all the schematics and just draw them up, and I can just, if I need a servo, I can just pick it out of the library and place it here. But this one here, I'm trying to determine to when I have the chest piece made for this alien, and I'm going to show y'all that later. And I need to make sure that I have clearance on the skin, because this whole alien is going to be like a bust. And then the chest piece and the neck has to be designed, because this is going to have to be in underneath that whole skin area, and it has to rotate. But the neck is what's going to rotate, and the chest piece is not. That so-called rubber, or the silicone chest and neck, all that's going to have to be glued down to the so-called chest plate, I guess, its plastic part underneath it is going to be a support for that skin, so I can attach the skin to that chest plate. That way, when this thing rotates, it's all that part's going to stand still, and the head will rotate and tilt, look up and down, more natural looking. So this is why I'm designing this gimbal. It has to be a tight design, so uh, you know, to cut down any kind of space or whatever. And I might have to tilt these servos up and remove the so-called plate that I designed on the sandwich in between the two hubs. But I'm making servo sockets for these servos here. But once again, I could bypass the plate and connect the two servos to the so-called beam. And this go directly to make it more narrow, I guess, because the servos are going to have to turn with the base. There's no other way. You can't have those servos off that base because it just won't work that way. It's not mechanically correct. But as you see here, and I'm going to rotate it, and you see how everything turns with it. That's the rotation of the bottom servo. And to get it to tilt, you'll have the two servos on the bottom doing that, but you can pull one and it will tilt to the right and raise up the other one, and it'll have a really good tilt mechanism as you see here. But when you combine all three of them, you'll have a full gimbal. So later I need to design a chest plate to hold the so-called servo block in place. And all that's going to have a hole on top of it to go up to the head. So now what I'm going to do is I'm going to do a STL file of the whole thing here, and I'm going to put it in the ZBrush and see how far adjustments that I need to make. As you see, the skull is bigger than I had designed, so I mean that's just part of it, and more likely I will reduce a lot of this because this is just a sketch of the skull. So I'm going to manipulate this sculpture here to fit this, and we're going to, see what it looks like. And this is fun to me. I enjoy doing this part. But I want to thank everybody for subscribing again, and all the comments and the likes and the sharing, and I appreciate it. Now I got things set up where I'm sorry you're going to have to start seeing ads, but that's the way I can produce some kind of income to support this channel. And I also have it where they call it a super like. If you want to donate to this channel, you can. But once again, I will have a Patreon set up soon. But I'm setting up all the so-called I'm getting all the information to all of my suppliers and servos and things like that, and even the beads that we're going to need to make this animatronic possible. And I just want to make sure I have enough of the supplies for the demand it seems like we're going to need. But now, as you see, this gimbal's been made. That's going to be an added 3 more servos to this whole animatronic, so we got a total of 11. But you see here, I'm forming the neck, and this, it's going to be like a bust shape. And I still not quite sure if it's going to be this tall or not. Even though I have that 9-hole piece of aluminum, I can reduce the size of it and raise everything up some. But if I raise it up, it's going to jeopardize maybe some of the shape of this so-called skin around the neck. But it's something that I'm willing to try to just see if it can work, and I can manipulate the so-called servos onto the beam itself to narrow everything down. And the smaller it is, it's more easy to mold and more easy to print to make the mold for the skin. So that's another thing. And once again, the smaller it is, the smaller the printer also. But I just sketching some kind of design. I kind of want a neck similar to this. I mean, it's going to be and when the skin's made, it's still going to have to stretch over the head. And don't get me wrong, there might be some time I might have to make cuts and repair it, but I'm trying to avoid that also. The closer I can get where I don't have to do that and just make one big mini mask out of silicone is my goal. So I'll just manipulate this and add some textures to it, and that way I can do uh, a low poly version of this and bring it in there to help me design my so-called bus shell around that servo block. Yeah, I got almost 6,000 subscribers now, and they said 5,500 in less than 28 days. That's a big achievement. And I just received 4,000 hour watch time, and they say that they I heard that that's pretty hard to do and within a month, but I, it's just that y'all have an interest as I do, as everybody kind of wants to make animatronics. But this is the neck I've designed, but I'm happy with it. It's just something to see a neck on it, but I'm just trying to see if I should later on, it's always making some kind of minor adjustments and even major adjustments. But we're going to have this thing up and running soon. But this is the big planning area just to make sure that I mean, everything has to be precise and measured correctly. But what do y'all think? If you like it, y'all hit that thumbs up and hope that gives y'all ideas for y'all animatronics. Well, I hope this helps. I mean, we're going to get this thing up and running. We're going to make some more adjustments, and we'll get this animatronic completely made as far as the whole mechanism working and moving, and then we're going to start on a core, and then we can start on a final version of the sculpt. Y'all have a great day. Later.